When we make a buffer by titrating a weak acid or a weak base, we titrate it into the buffer region. Here we've taken the weak base, ammonia, and we've titrated with HCl into the buffer region, so a third of the way to the equivalence point. So we start by writing out our conjugate pair, straddling the equilibrium. We have ammonia and the ammonium ion. Remember, the ammonium ion will be generated as the titration proceeds. Because these are a conjugate pair, they're going to straddle the equilibrium, as we mentioned. And so ammonia in water will give us the ammonium ion and the hydroxide ion. Now we need to know how many moles we have initially of ammonia, how many moles we start with at the beginning of the titration. So we use the volume that we're given and the molarity that we're given. Oops, wait a second, that's not the molarity. 1.2 molar, and that gives us a total of 0.024 moles. Now for our IREC table. Initially, and we don't mean initially in the titration, we mean initially, once we've got a third of the way to the equivalence point, we will have 2/3 of our initial moles, so 2/3 of the 0.024 moles. And we will have generated 1/3 of 0.024 moles of ammonium ion. We'll say we start with 0 moles of hydroxide, so immediately we know we need to shift to the hydroxide to create X moles of hydroxide, X moles of ammonium ion, and we'll lose X moles of ammonia. So at equilibrium, we can write the moles at equilibrium that we would have. And then, of course, to generate the equilibrium concentrations, we would take the equilibrium moles and divide them by that total volume. Remember, you don't need to figure out the total volume at this stage, because by now you've learned that they cancel out in the final calculation. So remember, this is a weak base, so we're going to be using a Kb expression to find the pH. So the Kb of ammonia, we have the ammonium ion times the hydroxide ion molarities divided by the ammonia molarity. It's the hydroxide molarity we're interested in to get our pH, so we rearrange the equation to solve for the hydroxide ion molarity. The hydroxide ion molarity will be Kb times the ammonia divided by the ammonium ion. We'll leave Kb as it is. We'll put in those equilibrium concentrations of ammonia divided by that volume, and the ammonium ion divided by that volume. You notice that there are those X terms in there, which could make the math difficult, but we'll make an assumption to get rid of those. So this term will be approximately equal to Kb times 2/3 of 0.024 divided by 1/3 of 0.024. Remember, this assumption will be valid, ignoring X will be valid, if X is much smaller than 1/3 of 0.024. So that 0.024 minus X is approximately equal to 0.024. This molarity then can be calculated. 3.6 times 10 to the minus 5 molar. Of course, the units are missing there. Oh, Roberta. pOH then is found to be 4.4, but that's pOH. pH, we need to take 14, subtract 4.4, and that gives us a pH of 9.6.